Okay, this is question 7. So this question is about waves. The diagram below shows a ripple tank, and hopefully you'll remember seeing that in class. Okay, it's used to study the behaviour of water waves. Water waves are produced by the vibrating wooden bar, so that's vibrating there. And the shadow of the wave is projected onto this screen below the tank. The waves appear to move in the direction of the arrow. Okay, so we've got the arrow moving that direction. All right, what we might notice straight away is that this is our tank and this is the screen that we're looking at. And you'll notice that the screen is longer than the tank, okay? And we can see there that the distance between successive waves is smaller there than it is there. That piece of information is going to be useful later on. So the screen is 80 centimetres long. The approximate wavelength of the waves on the screen is, so here we need to count how many waves we got. So 1, 2, 3, 4, 5, 6, 7. Okay, and I think we count up to 20. Okay, so the screen is 80 centimetres long and there are 20 waves. Each of those waves is 4 centimetres long. Okay, 80 is all those waves. There are 20 of them, so each has got a wavelength of 4 centimetres. A student uses the image produced on the screen to estimate the speed of the water wave as 75 centimetres per second. The reason why this is an estimate is not correct is, okay, so this is this problem we have with the speed of the water wave being 75 centimetres per second, but if we're measuring using that scale down there, that length is much longer than that length. Okay, so if it appears to be travelling 75 centimetres a second here, okay, it's not travelling as far as 75 centimetres before it gets projected. So the actual wave is travelling a much smaller distance every second. So the reason why this estimate is not correct is because the wave seen on the screen is magnified. Okay, page 2 of this then. So describe how a student could measure the frequency of the waves in the ripple tank. So he could count the number of waves and passing a point. Okay, so that's kind of going to get you the first mark in a set period of time. Okay, and then calculate frequency using calculate frequency using frequency equals number of waves divided by time. Okay, and that will tell us how many waves per second. Okay, you're not going to be able to count the number of waves in a second. Okay, so if you count the number of waves passing a point, okay, in a set period of time, so say that's 30 seconds, you count the number of waves in 30 seconds, you divide the number of waves by 30, and you get the number of waves per second. Okay, the settings on the ripple tank are changed. The waveform diagram shows the properties of new wave made by the ripple tank. And we can see here that we've got a mark there of 0. Okay, so that is the undisturbed position. So that is the wave when the water is not moving at all. Okay, it's at that undisturbed position. So the wave goes up to its crest here, okay, and down to the bottom of its trough here. So state the amplitude of the wave. Okay, so the wave, the amplitude of a wave is the height, okay, from the undisturbed position to the top of a crest, or the height or the distance from the undisturbed position to the bottom of a trough. Okay, and on this graph that's 4 millimeters, sorry. So there we have 6 millimeters if I read across to my graph. So the amplitude is 6 millimeters. The wavelength of the wave, well, the wavelength is the distance from the same point on 2 adjacent waves. Okay, and I've got a peak of a wave there and a peak of a wave there. Okay, each of these boxes is a half, so 2 boxes, that's 1, 2, 3, 4, 5, 6 centimeters. Okay, you could have measured it from there to there, okay, or from a trough to a trough, all right, but I've picked that as being possibly the easiest bit to measure. Okay, so 6. The frequency of the wave is 5 hertz. Okay, so we've got a calculation, so we're going to use our heist technique, and first thing we're going to do is highlight our question. So the frequency of the wave is 5 hertz. Use your answers to B part I to calculate the speed of the wave. Okay, so B part I is telling me the wavelength of the wave. Okay, so that's my value for lambda, okay, the wavelength. Frequency is equal to wavelength multiplied by, wave speed is equal to wavelength times frequency. Okay, there's my equation. I'm now going to insert my values. So our speed is the thing we're looking for. Okay, so we're going to leave that unchanged. Is equal to wavelength, where our wavelength is 6 centimeters. Okay, and we want the answer in centimeters per second, so that's fine. Our wavelength is 6 centimeters multiplied by the frequency. Okay, and the frequency is 5 hertz. Okay, so V is equal to 6 times 5 is equal to 30. So the wave speed is 30 centimeters per second. Okay, that's the end of that question.